I wanted to take a few minutes just to look at a few more examples of the law of sines, just to illustrate the different kinds of things that can happen to you when you're dealing with law of sines type problems. So remember that the law of sines says the following. If I have some kind of triangle here, and I have got angles A, B, and C, and I have sides, capital A, capital B, capital C, then the law of sines says that the sine of little a over A equals the sine of little b over B equals the sine of little c over capital C. Remember, I'm putting the little dash under the C, the little underline, just to make sure that you guys know that that is supposed to be a capital C, because otherwise, with my handwriting, you would never know the difference. All right, so I mentioned that there are a few different things that can happen with this law of sine stuff in some situations. And I want to just illustrate what can happen with a few scenarios here. So I want to think about the following kind of setup for a triangle. And we're going to solve the triangle, meaning we're going to find all the dimensions of these triangles. So let us suppose that I give you a triangle and I tell you, let me try to draw this somewhat in the shape that I want it to be. So let's say that I tell you that this is an angle of 30 degrees. And I also tell you that this side of the triangle is a length of 1. So this is the original setup, and then I need to tell you something additional. So I want to do some side-side angle cases, meaning that we're going to have two sides and then one of the angles, which is not in between them. So what would happen if I were to tell you that, in addition, this side of the triangle has a length of 1/4, and I ask you to find the other dimensions of the triangle? Well, what you would find when you try to work out this example, what you're going to find is that this is impossible. You cannot have this situation. Such a triangle cannot exist. So it makes it a little weird because I'm trying to draw for you a triangle that can't exist. And the reason that it can't exist is because the shortest length that's going to work here is going to be a length of 1/2. The sine of 30 degrees. But let's see why that would be the case. So the reason why this would be the case is because, assuming that such a triangle could exist, let's call this angle little b. Then what we know is that the sine of 30 degrees over 1/4 should be equal to the sine of little b divided by 1. That's what the law of sines tells us. And from this, well, I know what the sine of 30 degrees is. I picked 30 degrees here because it gives me a relatively nice number. I don't have to plug it into a calculator. But in general, you plug this into a calculator, you get a decimal approximation, and that's fine. Well, here's the thing. I turn this equation into 4 times the sine of 30 degrees is equal to the sine of little b. Now, the sine of 30 degrees is 1/2. Hopefully you guys remember this. So this means that 4 times 1/2 equals sine b. And this tells me that 2 is equal to the sine of b. But this is impossible. Why is this impossible? Can anybody think of a reason why this would be impossible? Take a minute to ask yourself what the issue is here. So, if you remember the range of the sine function, 2 is not in the range of the sine function. So this equation, there's no angles whose sine is 2, okay? We can't build a triangle like this. Geometrically, what is happening here is, I think it's really important to visualize what's going on here geometrically. The length of this dashed line is 1/2. Whoops, that's not a fraction. That's just a 1/2. The length of this dashed line is 1/2, and that is the perpendicular. The shortest distance between this point and this bottom of the triangle is this perpendicular line, right? The shortest distance between a line and a point is if you go perpendicular to the line. Well, that means that the shortest length for this side of the triangle is going to be 1/2. If I tried to make this 1/4, then essentially, like, think about building this triangle physically. You lay out something of length 1, and then you lay out something of length 1/4 up here. No matter how you twist that thing around, you can never reach this side. There's always going to be a gap. And that is what this is telling you. This is not a possible triangle. It can't geometrically exist. So this is one of the situations you can get into when you have side-side angle and you're working with the law of sines. Now, second example of what can happen to you. Let's go back for a moment and let's work with the same basic setup, but let us suppose that this time I tell you that this side has a length of 1/2. If I go ahead and I use the law of sines, I'm going to see that the sine of 30 degrees divided by 1/2 is equal to the sine of little b divided by 1. Okay, so very similar setup to what we had before. But this time, this is going to become 2 times 1/2 equals the sine of little b. This means that 1 is equal to the sine of little b. And this is good because this does have a possible solution. So b could be equal to 90 degrees. Now, something you want to be careful about when you're doing these types of problems. We are trying to build a triangle here, okay? We want a triangle that actually can physically exist. So note, b is in the range from 0 degrees up to 180 degrees. So we want all angles from 0 to 180 degrees whose sine is equal to 1. The only option here is 90 degrees. Now, why does b have to be between 0 degrees and 180 degrees? Well, it's because a triangle has to have all of its angles add to 180 degrees. So none of my angles can be bigger than 180 degrees. In fact, none of them can equal 180 degrees, because then the other two angles would make it bigger than 180 degrees. In fact, in this particular case, since this is a 30-degree angle, I know that it really, for this particular problem, has to be 0 degrees to 150 degrees, because if it were bigger than 150 degrees, then my angles would add to be too large. Okay, so we'll think about that more in one of the examples we'll see in a minute, but that's something else to keep in mind. But in this case, the only option is 90 degrees, and that works fine. So once I know that this is an angle of 90 degrees, then the rest of this problem is fairly straightforward. So I'm going to leave it to you guys to work out the rest. Once I know that this is actually a 90-degree angle, I see that this is a 60-degree angle, and it's a simple matter to figure out what is the length of this bottom. It comes out to be square root 3 over 2, but I will leave it to you guys to work out those details. Now, what if I ask you the following question? So we're going to start again with the same kind of a setup. And I'm going to say that this time, this side is going to have a length of, what do I want this side to be? What if I make this side have a length of 2/3? And all I ask you to do is to find the angle little b. So we're not going to worry about solving the entire triangle. I really just want to show you the different things that can happen here. The last step of getting the last angle on last side, those are kind of the same no matter what. But I want to show you the different things that can happen here. So what does this tell me? Well, from the law of sines, what I see is that the sine of 30 degrees divided by 2/3 is equal to the sine of little b divided by 1. You should notice here that all of these first steps are very similar. That's because they all literally just come from the law of sines. We're just plugging in the particular information in this particular triangle. So what we can say at this point is this means that 3/2 times 1/2 is equal to the sine of b. And we can also say that, well, this means that 3/4 equals sine of b. Now, the thing is, we know that this angle b plus 30 degrees has to be smaller than 180. So b plus 30 has to be smaller than 180. We also know that 0 has to be less than b. That's because this is actually an angle in a geometric triangle. So all of the angles have to be between 0 and 180 degrees, and they have to total 180 degrees. So this means that b has to be smaller than 150. We also know b has to be bigger than 0. So we get two possibilities. We get the inverse sine of 3/4, and we also get 180 minus the inverse sine of 3/4 in degrees. Now, I don't know exactly what this is equal to, but what you will find is that both of these possibilities are smaller than 150 degrees, so they will both work, okay? Both are an option in this case. And I will leave it to you guys to throw this into a calculator and to verify that, yeah, these really are both in the 0 to 150 range that we want them to be. So we actually get two choices here. Let's take a look at the next kind of situation that can happen. All right, so what if I tell you that this side is actually of length 1 as well, and this is an angle B, and I want you to find B. Well, in this case, what we would say is that the sine of 30 degrees divided by 1 is equal to the sine of B divided by 1, and this tells me that the sine of 30 degrees equals the sine of B. So this means, well, we'll come back to what this means in a second, but observations. We know that 0 has to be less than B, and we also know that B plus 30 has to be smaller than 180. The 30, again, it comes from the fact that this angle is 30. It's not like you just plug in 30 there. It's literally that you have to have that 30, whatever that angle is that you know, plus this new angle, they have to total something smaller than 180 degrees. Now, initially, there are two possibilities that you might think of here. One possibility is that B is equal to 30 degrees. And that is fine because that is smaller than the 150 degrees. And 150, this angle over here cannot be 150 or bigger. It's got to be smaller than 150 degrees. The other possibility would be that if this has to be between 0 and 180 degrees, and it has to because this is a triangle, well, it could actually be equal to 150 degrees. But that is ruled out because actually we found that this angle needs to be strictly smaller than 150 degrees. So we only get one answer in this case. I want to show you guys again, geometrically, what was going on in each of these situations. In the previous situation, where we said that this side was a length of 2/3, there's really two different triangles that you could make. This side and this side, these are the same length. So you actually get one acute triangle and one obtuse triangle that you could have, both as a possibility. The idea is if you were building this triangle, you start with this angle 30 degrees, you put down a length of 1, and then you have a length of 2/3. Well, as you think about all the different ways you could swing this side of 2/3, there are two different places where you can swing it into that still build you a triangle. Now, when I pushed this length up from 2/3 to 1, what was happening is one possibility was that you get a triangle like this. It is actually an isosceles triangle where these two sides are the same length. Now, the other possibility would be that I swing this side over to here. But in that case, I would no longer even have a triangle because then these two sides would actually coincide with each other. So there's actually only one triangle possible in this case. One more option that we could end up looking at here. So what if I give you this picture, I tell you to find B, and I tell you that this side has a length of 2. Well, in this case, again, what we know is that for this setup, 0 is less than B, and B plus 30 is less than 180, which means that B has to be strictly less than 150. Excuse me. So what I can say is, again, sine of 30 degrees divided by 2 has got to equal sine of B divided by 1. And this means 1/2 divided by 2 equals the sine of B. That tells me 1/4 equals the sine of B. Now, a priori, there are two possibilities here that I need to think about that lie between 180, or between 0 and 180 degrees, I should say. So there's the inverse sine of 1/4, and then there's 180 minus the inverse sine of 1/4. But here is the problem. When you plug these into your calculator, what you will find is that this one works, but this one is bigger than 150, and therefore it does not work. In other words, this whole thing, 180 minus this inverse sine. The reason is because the arc sine of 1/4 is smaller than 30 degrees. Okay, because it is smaller than 30 degrees, 180 minus that is going to be something bigger than 150. And so that is ruled out. It is not a geometrically possible triangle. What is going on geometrically here? Let's try to visualize what's going on with your triangles. What you have is, if this side is length 2, it would actually really come all the way out over to here probably, or somewhere thereabouts. Well, if I tried swinging this side over here, I could build a triangle out of a length of 1 and a length of 2, but it wouldn't be this triangle anymore. It wouldn't have this 30-degree option. So I do get a possibility, it's just not the right triangle, and therefore I don't care about it. So to summarize what we have seen here, when you are dealing with side-side angle and the law of sines, there are really a few different possibilities that you can get. You can get an impossible triangle because let's say that this is given, and this angle is given to you in the problem. You can get a side here that is impossibly short. You can get one where those are the three givens, and you can get one where the only solution is a right triangle. That was kind of our second example. So if these three sides are given, let's just come up with labels for the sides that are given. We're going to say that this is angle little a that's given, this is capital A, and we'll say that this is capital B. So those are the three givens. So one possibility is that this side, capital A, is too short to build a triangle with it. Another possibility is that this side A is exactly the right length to build a right triangle, and that's the only thing you can build from it. A third possibility is that you are given dimensions where two possible triangles can be built. In other words, you could build an obtuse triangle, or you could build an acute triangle. So that is a third possibility with the law of sines. A fourth possibility is that you get an isosceles triangle, and that happens when you have A set equal to B. In this case, you can build an isosceles triangle, and that is the only thing that you can build. The final possibility is going to be that A is bigger than B, and in that case, what you're going to get is that the only possibility is going to be this big triangle over here. The other possibility would swing us around, and we would get a triangle on the left-hand side, which would be a totally new, different triangle, and so it's not one that we are interested in. So let's think about what is going on in each of these cases. In this first case, what we get is that A is actually smaller than B times the sine of little a. In the second case, we get that A is equal to B times the sine of little a, and that means that this is actually a right triangle. In this third case, we get that B times the sine of A, that would be this perpendicular line that I just put as a dotted line here, is smaller than capital A, which itself is smaller than B. So in these cases, you get two possibilities. This case, of course, is just when A is equal to B. That we already sort of know what's going on here. And this is the case when A is bigger than B. So, 5 kinds of situations. The impossible case, a single right triangle, 2 possibilities, an acute and an obtuse triangle, 1 possibility, an isosceles triangle, and finally, 1 possibility, this big, long, wedge-shaped triangle that you end up with. Now, we've gone over examples of each of these, but it is really important that you guys practice these yourselves, because you don't really internalize this kind of information until you've practiced this kind of stuff yourself and looked at it, looked at more examples. So I do want you guys to, again, where is it in the books? I lost the page in the book somehow. Probably because everything fell off of my desk a few minutes ago before I actually did this. Yeah. On pages 684 and 685, they give you some examples of doing this stuff that I really want you guys to make sure that you look at. These are examples 3, 4, and 5 in section 9.2. And the stuff that you do for practicing. Now, I'm not going to do a lot with you guys on law of sine stuff, but this is stuff that you might need to know in future. So, you really need to remember that there are these different possibilities that you can get when you're working with the law of sines. All right, hopefully that was not too super confusing. It does seem confusing when you first see it, but rewatch the video again if you feel like you're confused. And of course, let me know if you guys have questions. This is one that I do think you would benefit from watching it a couple of times to see what's going on. Because now that you know where we're going with all this, maybe the stuff at the beginning will make a little more sense. And one of the nice things about having these lectures recorded instead of in person is you can just go back and rewatch whatever you want to. You can just rewatch the first few examples. And as you do it, try to think about how, oh, that is this case that we're seeing in general. But like I said, if you guys still feel confused after that, do feel free to let me know and we can talk about this more. But hopefully you guys will be able to figure this sort of thing out and understand those examples in your book. Otherwise, next time we're going to be talking about the law of cosines, which fortunately is a little bit, let me put it this way. It doesn't have this level of complicated, many different cases. It's a bit of an annoying formula, but once you get that formula, that's it. That's all you're going to do. You're set. All right, I will talk to you guys then.